equation of the normal at the point -2, 3 of the circle of this equation. Let's do that. So solution. We have to find the equation of the normal. First of all, what is a normal? You have to understand this. So when you say a normal, assuming this is a circle of this equation and this is a center, all circles have a center. So the line that passes through the center to form perpendicular with the tangent, meaning to form what? 90 degrees. To form perpendicular with the what? The tangent. That line is known as what? The normal. So this line is the normal line to the circle. Good. And we have been given a point. So a point for the normal as what? -2, 3. So this is the point. And you have not been given center. You have to find the equation of the normal. You need the gradient to get the equation of the normal. So you need another point. And in this case, since there is equation of the circle here, you can derive the center from the equation of the circle which is being given. So our center here is not known. Now let's do that to get the center. So I'll write the equation which is being given: x squared plus y squared minus 4x plus 2y minus 27 equals 0. Good. After that, I'll write the general equation of the circle beneath it, which is plus 2jx plus 2fy plus c equals 0. So now what am I going to do? I'm going to compare the coefficient of x. So for the first equation, coefficient of x is -4. Then I will equate it to this one, the coefficient of x here, which is 2j. So I divide by 2, divide by 2. So my j is -2. Now my y, that's the coefficient of what? Y. So we are going to equate it. So 2 equals 2f. You divide by 2, you divide by 2. My f therefore is 1. And remember, to get a circle, we have to negate the j and negate the f, because the circle is in the form -j, -f to get the center of the circle. So when I negate the j, I get 2. When I negate the 1, I get -1. So the center is 2, -1. So now I have my center and I have this point, which is for the normal. So what am I going to do? I'm going to get the gradient from this. So from the center to this point, which is the radius, I'm going to find the gradient of this radius. So it will be m, which is the gradient, y2 minus y1 over x2 minus x1. So my y2 is 3. So 3 minus my y1 is -1 all over my x2 is giving us -2. So -2, my x1 is 2, so -2. So it will be 4 over -4. So my m becomes -1. So -1 is the gradient for the radius. Now I want the gradient for the normal. Since the normal is passing through the same place the radius is, the normal also have the same gradient as the radius. Good. So now my normal, so for the radius m1 is -1, and my normal, which is m2 gradient 2, is also -1. And the point which is being given for the normal, which is -2, 3. So my x1 is -2, my y1 is also 3. So now let's find the equation of the normal by using the point slope formula, or the point slope form, which is y minus y1 equals m x minus x1. Now let's plug in the values which is being given, which is 2 and 3. So y, which is constant, minus y1, 3, good, equals, the gradient is -1. So x minus x1 is what? -2. Good. So y minus 3 equals -1. This one will give you positive x plus 2. So y minus 3 equals -1 times x. We expand the negative x. -1 times +2, -2. Good. So now what I bring here, we'll make sure our negative x move to this side of the equation, becoming positive x. We want to write our answer in the general form of equation of a line. So our x will be here, our y is already at the left hand side, so positive y. Then there's -3 here. This -2 will move to the left hand side, becoming +2, all equals 0. So x plus y, -3 plus 2 gives us -1 equals 0. So this is the equation of the normal of this circle. Thank you very much.